That tonight. So I appreciate you coming out, having me come out tonight and talk a little bit about weather. I have a presentation and we can work through it, as a typical presentation, or we can have it as a dialogue and a conversation. If we stir some conversation, just let me know and we'll move on. The first thing is, what the heck is the National Weather Service? When people ask me what I do, the first thing I say I'm a meteorologist, they ask what station I'm on. That's the first question you always get as a meteorologist. But I work in the National Weather Service. The National Weather Service is a federal agency. We are under NOAA, which I'm sure a lot of people are aware of, the National Oceans and Atmospheric Administration, and that's under the Department of Commerce. So that's kind of the chain of command that we fall under. We are located just down the road here on the Florida State campus. So the office for Tallahassee that serves as part of Florida and Alabama and Georgia is located on Florida State campus. We moved to the FSU campus in 2002. We used to be down at the airport where our radar still is. We moved to the campus to be co-located with the Meteorology Department. Florida State has a very large Meteorology Department, and we wanted to be a part of that. And there are a few offices in the nation that are co-located with the university, and this is one of them. So our main mission, basically, it's in bold there. Our primary mission, when everything boils down, is the protection of life and property. And obviously there's a few other things there with climate and maintaining our database. But the key thing is protection of life and property. That's how we fit into the picture. There's a lot of private meteorology companies. People get forecasts from a lot of different folks. We have media, obviously. TV meteorology is a big thing. You got the Weather Channel. But our primary focus is, what it boils down to, is we issue the watches, warnings, and the life-saving information. And that you really have to structure it that way, because you can't have private companies contracting out, issuing warnings with different cities, and nobody would really know what to do and who would contract with who. And we'll talk a lot about uncertainty, and that's what we deal with in this field, is a lot of uncertainty. So the way it's structured is the federal government does maintain the watch and warning programs for the nation. So this is what it looked like when I started in the National Weather Service. At least it feels that way sometimes. But the National Weather Service started with the Signal Corps way back when, under the military, Department of Defense. It evolved into the Weather Bureau, and then eventually into the National Weather Service, and we went under the Department of Commerce. So here's the structure, here's the puzzle piece of National Weather Service offices. So each one of these colors and each one of these dots represents where a National Weather Service forecast office is and their area of responsibility. So you can see TAE, those are our call letters for our office here in Tallahassee. The state of Florida actually has 7 offices that serve a part of Florida. You have Mobile that serves the area around Pensacola. You have Tallahassee, Jacksonville, Melbourne, Tampa, Miami, and Key West. A question there?
Which office is responsible for telling Jim Cantori?
None of our offices are responsible for Jim Cantori in any way, shape, or form. But so it's this white structure has about 125 National Weather Service offices in the country. Now these are just local offices. There's also national centers. There's 7 big national centers. The National Hurricane Center is one that everybody knows about. The Storm Prediction Center in Norman, Oklahoma, another big one. There's even a Space Weather Prediction Center dealing with solar flares and things. So we have national centers. Their focus is nationally on a specific phenomena. So the Hurricane Center, they're the experts on the tropics, and that's what they focus on for all the Eastern Atlantic and really all the Atlantic Basin and the Eastern Pacific. While the local offices here in Tallahassee, we focus just for our area for all things weather, essentially. This is who we forecast for. This is our area of responsibility. It's a pretty large area that we serve. We have about 1.7 million people in 48 counties and parts of 3 different states. So we have 3 states, 2 time zones, so it can get a little challenging at times trying to schedule webinars and things of that nature to brief. But we have a pretty large area, including the Gulf of Mexico, so we do serve out over the Gulf for a ways there. We issue special marine warnings and do forecasting for marine interest out over the waters. So the current Weather Service operations look something like this. We have just a series of workstations. Our office, our staff is not really large. You think it would be really big, but it's not. We have a team of about 10 forecasters and 5 observers that rotate through. We have anywhere from 2 to 4 people on 24 hours a day, 7 days a week. Our total staff is just about 25, 27, some in that range. So it's not real large, but we're there 24/7. Being a weather forecasters, it's kind of a hard life because we work rotating shift work. Well, I'm not a forecaster right now, I'm in management now, but I was a forecaster, it's rotating shift work. So you work like a week of days, a week of evenings, and a week of nights, and you rotate through once a month. Typically we have anywhere from 2 to 4 people on 24/7, but on a big event like this picture is taken during our February floods of last year, about a year ago, we had a lot of heavy rain and a lot of flooding, river flooding. In those situations, or if a tropical storm is approaching, we'll have every workstation manned. Everybody has a responsibility in doing what they need to do. In those cases, the big events will also go to 12-hour shifts. So not only in a big event will you be doing your routine products, which we can talk a little bit about, but we also do a lot of high-end support, just really specific, what we call decision support for decision makers, for the counties, the states, any communities. We do a lot of webinars and special briefings where we make sure everybody really is on the same page. That's one thing that the Weather Service is getting a lot better at, is trying to make sure that people understand what we're trying to say, the threats that we're dealing with, and the amount of uncertainty that we're dealing with. It used to be, when I came to the agency, we basically would send out a lot of products and we would train people how to interpret those products, but we're realizing it's not as an effective way to work. So now we're trying to focus more on the service and make sure that if someone's making a decision at a football game or a basketball game, they really know what they're dealing with and the amount of uncertainty that we're dealing with. But we have a number of computers. Everything's gone digital essentially. So instead of just sitting and typing forecasts like we used to do, now we do everything in a gridded format and it spits it out. So those forecasters spend most of their time on these monitors, maintaining the grids. Every few hours they bring in a new update of a model, a simulation, and see how that changes the forecast, and they tweak things as it comes out. So one thing about meteorology never deals with certainty. We like to think that we deal with certainty, but we don't. Or at least very rarely will we ever deal with certainty. There's a lot of uncertainty that we deal with, and uncertainty is a broad term. But there's some big things that we deal with. There's some uncertainty in what we understand. That's the first thing. It's still a science. It's a growing science. Meteorology in its current form has really only been blossoming since after World War II. So there's so much that we're learning, and there's so much that we're being able to identify now and simulate with the high-end computers. As computers get more powerful, we're able to simulate things better and say, hey, that looks actually kind of real. So we're actually getting, we're learning a lot. So the big thing is, first thing is what we understand. The other thing is what we see. You can only see so much. We don't have observations every square mile in the country. We don't have radars everywhere. We have a pretty good coverage of radars. We have the best in the world. But there's still gaps in radar data. We can't see what's out over the oceans. We can see it out of satellites, but we don't have observations of what's actually going on down on the ocean surface. Another big thing that we deal with a lot, and that we're learning with, and we're dealing with emergency management a lot more carefully, is we don't really know what the impacts are going to be. We could say we have a thunderstorm moving in with 50 miles an hour, winds of 50 miles an hour. We don't necessarily know what those specific impacts are going to be. The snowstorm that just bottlenecked Atlanta a few weeks ago, that was accurately forecast. They said 1 to 2 inches of snow, but the impact, we weren't really sure what that impact was going to be. Well, the impact was catastrophic, essentially, because the snow fell and it just flash froze. Those are things that we're learning. So there's a lot of uncertainty that you're dealing with. It's a very humbling field. You can't be a meteorologist if you don't want to be wrong. It just comes with the territory. If anyone's making a prediction on anything from sports to whatever, stocks, you're going to be wrong. And that just comes with the territory. But all these things that I list up here on uncertainty, that's true from the longest range forecasting all the way down to current weather. There's always a lot of uncertainty. So the question is, how do you message that? How do you tell people with any sort of certainty that we're uncertain? And what do you do with that? If we could put out a 40% chance of rain, a 40% chance of a thunderstorm on an average June day, okay, and then we'll get a thunderstorm that'll move through Killearn, and it'll get heavy rain in Killearn. South of Tennessee Street won't get anything. So people in Killearn will say, well, they didn't say it was going to rain today. And the people in Southwood will say, well, they said it was going to rain today. They all got the same forecast. So just trying to understand that we're dealing with 40% chance of rain is one thing, but a chance of a catastrophic storm is something else. What do you do with that? What do you do with a 10% chance of a catastrophic storm? Do you evacuate a city, or do you that's a tough decision to make. I'm going to go a little bit about difference between watches and warnings, and I'll go with thunderstorm and tornado watches and warnings because it's easier to understand. But it's really the watch and warning program. It's pretty much that way on all the phenomena. But basically, a watch means that we are starting to get concerned. Watches usually cover a larger area. They go out a little farther in time, and it's kind of a heads up. A watch means to watch out, be aware. Depending on the hazard, if it's a hurricane watch, different things might be done. If it's a flash flood watch, might be do other things. But a watch means that, hey, things could happen. Typically for like a tornado watch, like this tornado watch here I have on the screen, that's usually maybe a couple hours out before the storms may even get there. The tornado watch can be issued when it's not even raining and it's blue sky out. A warning basically means to act now. So there's a big difference in a watch and a warning. It's unfortunate there are two terms with W's on them because it confuses a lot of people. And that's one thing as an agency we're learning. We're trying to figure out, well, maybe watch and warning may not be the best terms to use. Maybe they don't mean what to other people what we think they mean. One of the keys in communicating is having someone else understand what you're trying to say. That's a real problem with meteorology. It always has been, and it continues to be a challenge for us. But for a warning, for a tornado warning, for instance, a watch might be maybe a part of a county. We could have a warning go out just for northern Leon County, for instance. But when a warning goes out, that means this isn't the time to now think, what am I going to do? That's what the purpose of the watch is. For decision makers and for just the general public, when a watch goes out, that's when you think, what would I do if? So if I'm living in a mobile home, or I'm worried about my parents at a facility of some kind, at a hospital, that's in the watch phase is when you want to start making that thought process about, what do I do if a tornado comes? The problem is when a warning comes, you don't have time to make those decisions. But the one thing is, a watch and warning are meaningless if people don't act. There's social sciences are a really growing field in meteorology that we're working really closely recently with social scientists to try to understand a lot of these things about what motivates people to action. And some of the things they came up with is it takes multiple phenomena to get somebody to act. You just can't tap someone on the shoulder and they're just going to run. Usually it's a couple of things. Usually they have to hear the warning. They have to know that a warning's been issued of some kind. They need to understand what that means. What is that? And the key point is in the box here. They need to believe it, that the warning is valid, and they need to personalize it, that this actually means me. And then typically even that, sometimes it takes someone to confirm a threat. This is where spotters help us a lot, when we can say, instead of radar indicates a tornado, if we can say, trained spotters reporting a tornado 10 miles south of Tallahassee heading northeast, that has more weight to it, we found out, than just saying radar indicates. But it takes a lot of these things, maybe 3 or 4 of those, to get somebody actually to move. There's a story of a TV guy that I know in Wichita, Kansas, and he was doing a remote out in a park, and it was thunder and the storms are coming in, and a tornado warning went out. Tornado warning out for the area he's in, and so he's trying to brief people on air that this tornado warning is going, he's about to have to shut down and seek shelter, and people were standing around watching him. So at some point he had to stop and say, no, this means you. We're all under a tornado warning, and then they all took off and took shelter. So they didn't personalize that threat. They heard it, but they didn't think, oh, that's me. And so we're trying to deal with different ways. I mean, obviously, with everyone carrying these smartphones now, and these are getting more and more use, this is an avenue that we're exploring. The FEMA has put out wireless emergency alerts. You might have seen some of those go across your phone. It looks like a text. for tornado warnings and hurricane warnings. So we're hoping that that will help some of this, especially the personalization that, oh yeah, that means you, that I'm actually under a threat here. The other thing is what happens if you issue a forecast and nobody listens? So who was wrong? Who's to blame? But did the forecasters not communicate that well enough? Did they not really convey what could happen well enough? Or was it the decision makers, or was it the folks themselves who just decided that they were going to ignore it? Katrina, they were begging people to get out of New Orleans, but thousands of people decided to stay. What do you do with that? It's a tough situation. If nobody listens and nobody acts, we're just screaming out to the wind. So how do you get people to act? Obviously, if you yell shark, everybody's getting out of the water. But we can't yell shark all the time. We don't have that we can do. A true story, I was out there where rip currents are a real big problem for our state, and it's somewhat weather related. So we're trying to work with a lot of the beach communities to use some of our infrastructure to help get the message out when it's going to be a bad rip current day. And so I was at a meeting here a couple months ago talking to folks out of Panama City, and these first responders are telling me that they would literally be pulling people out of the water out of rip currents and performing CPR on someone, and people go, walk, why out of them get in the water? So what do you do in that situation? How do you get through to people that, no, this means you? I'm performing CPR on someone, you're getting right in the water. But they joke about it. We could just put a remote control shark out there and we throw it out of the water. Nobody's getting in the water. The Joplin, Missouri tornadoes. Anyone remember the Joplin, Missouri tornado a couple of years ago? 160 people killed. Just a tragic situation on multiple levels. And we're investigating it and trying to figure out what happened, because they did have a tornado warning. So you think in today's technology, today's world, and you have a tornado warning, how in the world do you have 160 people killed and then many, many more injured? Part of that is because the tornado was so big and large that a lot of people didn't have a chance. But they're looking at a lot of it maybe is with false alarm. This is a tornado alley. These people deal with a lot of tornadoes and a lot of tornado warnings, but they've never dealt with a tornado like this personally. So, all those folks that were at Home Depot, all the people that were just driving around on their daily lives, did they not hear the warning? Or did they have listening to iTunes on the car radio and they didn't even know, that the warning was issued? There are multiple factors here. But I came to Tallahassee from the Storm Prediction Center in Norman, Oklahoma, where I had spent the previous 15 years as a tornado forecaster for the country. And I thought in my lifetime we'd never see another 100 fatality tornado. The last one we had seen was Udall, Kansas in 1950. So I thought that those days, that was the old Weather Service. This is the new Weather Service. Surely that would never happen. And we've had a lot of big tornadoes since then, but we never had something with this kind of total. So it really was an awakening as the agency that we're not there yet for whatever reason. Maybe it's, like I said, the watch warning terms aren't good. Maybe it's people are too complacent. Maybe we issue too many warnings and they hear too many warnings on TV without getting hit individually, and so they don't really know what to do. It's probably all the above that we had to deal with. But you compare that with the Moore, Oklahoma tornado from last year, which was another big F5 tornado where we had 24 people killed. But it went through just home after home after home, and thousands of homes were destroyed in this tornado. And yet we had 24 people killed. Why is that? Why would Joplin get hit and we'd have 160 dead? And Joplin and Oklahoma City are not that far apart. So both in Tornado Alley. But some of the things, I'm going to go through some pictures here. I hope you can see these pretty well. These are some damage photos from the Moore tornado from some of the people who did the damage survey. This jumbled mess up there was an old Chevy. That's all that's left of it. This was one of those interstate billboards, those really tall, thick billboards. That's all that's left of that, just bent at the ground. There's nothing left of that. You can't hardly see here in the big screen, but there's a little green circle here, and 3 people survived this tornado laying in that, just underneath that big piece of equipment there. They were in one of those kind of prefab metal buildings that they do auto shops and auto repair or body shop or something, one of those type of shops. You can see a photo down here with a well-built brick home, and that's all that was left of it after that tornado. Same thing here. You can see the picture of the house and then before and after. with the trees and everything. It's hard to imagine how severe the winds were in something like this to do this kind of destruction. And if you've seen this firsthand, it's really eye-opening, obviously. But it's eye-opening because you can kind of go from nothing being touched to, maybe a few shingles off to just total destruction. It's literally like someone took a lawnmower through neighborhoods about a mile wide, and then everything else outside of it was just barely damaged. Here's Briarwood Elementary School. You can see kind of what's left of that. There were children inside of this school at the time. If you remember, the Morris tornado struck right at the end of school. So a lot of the canceled bus services, and they just sheltered the kids in place. There were kids here. There were many injured, but luckily no fatalities. Unfortunately, at Plaza Towers Elementary School, there were 7 children that were killed in a 3rd grade class when they were sheltering in place in the hallway, and everything kind of collapsed on them. Which brings a whole nother question that we debate, is what to do with children, what to do with schools. People say, well, how could you be in Oklahoma and not have tornado shelters? Well, they're very expensive to build. It's a tax issue. Anytime you try to get a bond issue to do anything, certainly I'm sure the districts would like to have gone back and done that. And where I grew up in Oklahoma, I'm in Oak, and actually all this tornado damage occurred about 5 miles from where I used to live before I moved here. But there aren't any basements there. There's a really hard clay subsoil, a high water table, and so not many basements just in general. So what was so different between Joplin and Moore, Oklahoma? Some of the things, Moore had been hit before. May 3rd, 1999, it was an F5 tornado, almost went through the same track. And I was actually there for that when I was working that event. It's a very, very similar track. Also, just the day before, there was an EF4 tornado just east of Oklahoma City that it was going live, and they were, everyone was seeing it. So people really personalized the threat. When this was unfolding, they realized what really could happen. That this could happen to them, and they had to take action. And false alarm wasn't an option for folks here. They didn't complain if they weren't hit. After Irene in New York City, not Sandy, but the previous year we had Irene that went up the East Coast. People complained that it was over forecast. It's like, really? You wanted a 10-foot surge? It's dumbfounding to me that people would get upset that they took protective action and it didn't happen. But that's what you deal with a lot of times. And Moore, that wasn't an issue. The other thing is Joplin was fresh in people's mind. From a few years ago, they knew what really could happen. So really, you go back to the chart I had up earlier. People did believe, and they did personalize. And they didn't worry about false alarm. They weren't worrying about if it didn't happen. They would be thankful if it didn't happen. So we think that some of the reasons there why that why there was a big difference in the fatalities between the two. So some of the obstacles that we deal with to try to protect the public go beyond meteorology, well beyond meteorology. A lot of it goes into psychology and social science. Complacency. We deal a lot with complacency on a lot of different levels. It never happens here, or it never happens to me. They always warn for our area, and we never get hit. So they forget. They just kind of blow off the warnings. False alarms are a big problem. That we try to be aware of as well. We want to provide warnings as needed, but we have to be careful, because if you cry wolf too many times, people aren't going to pay attention. We can't actually see tornadoes. I'll talk a little bit about this in a little bit. We see what we think could be tornadoes on radar, but we don't know if it is a tornado, so we might issue some false alarms. So we have to kind of be aware of that. When you're sitting on the warning desk, how sure are you? You can't. You would like to think it's a better safe than sorry approach, but it really isn't. People laugh at Homeland Security because it's always orange or whatever, what the threat level is. Same type of thing. People just get complacent, get too complacent. The other thing is a lot of people don't really understand the risks. Perhaps the people in Joplin realize this wasn't a normal tornado warning. This was you're going to die tornado warning. We'd like to think they're all that way, but people don't really understand the risks they're under. Hurricane Sandy, Katrina, you can look at a lot of examples where people didn't really conceptualize the risk. I was listening to a 911 tape years ago from Pensacola for Hurricane Ivan, where someone's dialing in and saying, I need help, I've got water entering my home and my father's in a wheelchair. And the 911 center, the poor dispatch operator's like, well, there's nothing we can do now. If your father's in a wheelchair and you're on the coast, why are you still there? The people don't really comprehend the risk. They think, oh, it can't be that bad. They always overstate things. There was a big river flood in North Dakota up at Fargo. This was about 5 years ago. And the river forecast was for, say, 26 feet. So they built the levees to be 26 feet. Well, it was 26 and a half feet. And, and there was some pushback to the Weather Service on that. It's like, listen, you've got to give us some room here. I mean, if we say 26 feet, why wouldn't you just go 27? Just in case we're wrong. Or 29 for you building your levees. So people, it's hard to get that message across, and that's why we're trying to do more personalized messaging the best we can. Some of it obviously is ignorance, getting people just completely oblivious to the fact. And a lot of people complain that basically, how can you not see? If we miss a tornado warning, people are just incredulous. How can you not see a tornado? Well, there are limitations with what we have to deal with. For instance, the principles of radar. Radar beams go in a straight line. Well, the Earth curves. So you can see as you get farther from a radar, you can't see very low on the ground. It's going to go out in a straight line and the Earth curves away. So by the time you get out towards 100 miles, the lowest you might be able to see is 12,000 feet into a storm or 8,000 feet into a storm. So you can only see so much, and there's not much we can do about that. That's just how that works. We don't have radars that bend with the curvature of the Earth. The other thing we can do is try to saturate the area with radars to minimize, where you just switch to a different radar. In this part of the country, Tallahassee is pretty well covered because we have a lot of radars. We have one here in Tallahassee, our 88D, which is our Doppler radars down at the airport. We also have a radar at Moody Air Force Base, at Eglin Air Force Base, at Fort Rucker, Alabama. So we have pretty good coverage here. Some parts of the country don't have that good of coverage, and it's a bigger problem, especially when you get out into the plain states. The other thing is a radar beam comes out as a cone. It's no different than taking a flashlight in a dark room and shining it on the wall. The closer you get in, the tighter that circle of light is, and the farther you get away, the bigger that light is. That's how radar works. So the farther you are away, you might be able to not be able to see winds coming towards and winds coming away in one single beam. It's going to average that out, for instance. See, here you can get you get 3 beams sampling a circulation. So this one here might sample winds going away, this one might kind of average it, and this one will have winds coming in. So you can have your red versus a little bit of white and then a green. You come out here, 120 miles out, you may not see a really small circulation. So there are limitations to what we deal with. So as a forecaster on the warning desk, you have to keep all this stuff in mind when you're trying to warn and protect people. So my biggest fear here, I get asked that a lot, my biggest fear for Tallahassee is a major hurricane for multiple reasons. What I have up here, this is actually our history of hurricanes that I could gather back to 1840. And believe it or not, we have a history of hurricanes here. It's been a really long time, especially with a major hurricane. We haven't had a major hurricane, which is a Category 3 or greater storm, hit in our area to impact us since the late 1800s. So we really have no real history for what kind of impact that will have. So that's my biggest fear. Most of these storms here were in the 1800s. For whatever reason, the mid to late 1800s were very active for us with hurricanes in this part of Florida, for this region here. The last hurricane to hit our area was 1985. Some folks might remember Kate. Here's Kate here. Made landfall around Mexico Beach and came up around Quincy and then up into parts of South Georgia. We had quite a bit of damage around town from Kate. I grabbed some pictures off the web from Kate. So trees down. Our biggest problem are going to be trees down. We love our canopy roads. We protect our canopy roads, but our canopy roads will come back to haunt us someday when we have a big storm because of all the trees coming down. The one thing about all these trees down in Tallahassee is that Tallahassee was never under hurricane conditions with Kate. It was a high-end tropical storm for Kate. People were out of power for weeks and weeks around Tallahassee for Kate. Does anyone remember Kate? Anyone here? Remember what time of year that was? It was like a Thanksgiving hurricane. It was right before Thanksgiving. So that's always my message, that hurricane season goes all the way to November. Once football season starts, you can't check out a hurricane season. It seems like once you get to about October, everyone's pretty much done with hurricanes. But you know, our last big storm was November 22nd in 1985, so it can be really late in the season. It was somewhat probably fortunate to not have power and be November, and not have power and be September, as far as humidity and everything goes with the air conditioning. But this was actually just north, whatever that county road is, just north of the, just south of the Georgia border there. It runs east-west, just north of Bannerman Road.
12?
Yes, it's 12. That's what that looked like up there, the devastation there going in towards Quincy. So, people who think that the cavalry's going to come riding in are going to be for a world of hurt, because it's going to take a long time to clear our streets to try to get to folks. Especially folks that might be living in rural areas, it might take a really, really long time. And if you combine complacency with what the impact could be, it's really a problem, and that is my worst fear. And for multiple areas, first of all, like I said, it's been several generations, and things that storms always go west. I hear that all the time. They always miss us. The other issue is that we have a lot of folks from South Florida who moved up here, who might think that a Cat 1 storm will have the same impact here as it does in Miami. A Category 1 storm can go across South Florida with not a lot of damage. A Category 1 storm here would be catastrophic for us. And so trying to get people to understand it's just a Category 1. Well, a Category 1 storm is sustained winds of 75 to 90 miles an hour with higher gusts, including tornadoes and everything else. So it would certainly be a devastating storm just to get a big storm. And if you think about a Category 3 storm, which would be magnitudes greater than Kate, so it's just a matter of time. And the question I ask people, who thinks that people are really going to act if we have a major hurricane coming here? Most people are not going to act. And this was the actual track from Ivan 4 days out. The Ivan track did suggest it was going to come up towards the Big Bend region. So people were actually starting to get worried a little bit. Well, Ivan ended up making landfall over near Pensacola. So it was way on the western edge of this track, and that's typically what happens, and that's what most people think. So what happens at day 2 when it's not gone west and it's still barreling down, and then everybody's clamoring at the same time to go get whatever groceries and whatever emergency supplies they can get? Good luck with that, because it's going to be a mess when that happens. So that's my biggest fear. I hear these quotes, they always miss us, they always go west, they always say get hit here, but they never do. We moved here because you don't get hurricanes. I've heard that before. Heard people who move up from Miami say, we moved up here because we got Andrew flushed us out and you guys don't get hurricanes up here. So we don't get as many hurricanes, but we can. So the question is, on a plot like this, what kind of messaging do I give people? Do I start sounding the alarms at day 4, talk about a catastrophic storm as something we haven't seen in 120 years, and then it ends up going to Pensacola? So it's difficult messaging to let people know this is what we call a high impact but low risk event. It's a low probability of occurrence. I shouldn't say low risk, but low probability of occurrence of a high impact event. It's a very difficult thing to plan for and prepare for. So what we ask for people to do, in hurricane season, just at least have a plan and have some supplies together so that at least you can get through some time. Because I think as a culture, we like to think that somebody's going to come help us. If you read survivor stories from Katrina and the Mississippi, especially the Mississippi coastline, they all say the same thing. Where is everybody? Well, they were all going to New Orleans. So folks would go weeks without seeing a National Guard's truck or a FEMA truck. The knight in shining army just can't come riding in. We really have to take care of ourselves, and communities tend to take care of communities in the immediate aftermath of major disasters. And I'm sure that's what happened here as well. So the better prepared people are, the better off they're going to be in the event of something happening. So real quickly here, I don't know how we're doing on time. I was going to go through some just basic tornado safety. We talked about watches and warnings. Basically get as low as you can and cover yourself. We want to get mobile homes and cars are not really good places to be. For kids, I always say just think at the duck. you want to get down, you want to get under, you want to cover up and keep safe. For tornado safety, ideally underground shelters. Here's an underground shelter from Moore, Oklahoma, where a family survived. Don't see a lot of that here, and you know, we don't have the tornado frequency they do out in Oklahoma, especially the really big, massive ones that you can't survive if you're not below ground. But out there, they do have the underground shelters, and here's another safe room in Moore, Oklahoma. Obviously, the lowest level. This was actually the one on the left. There was Hattiesburg, Mississippi. That was like a near the campus there, where the top floor went down, you know, collapsed down. So that's why you want to be on the lowest floor. You can see here out maybe in this case how the stairwell is the only thing that survives. So anything, you know, under a stairwell, anything that has that can bear a lot of weight will do you a lot of good. Large open spaces are bad. Gymnasiums are bad. Anything that's like this here, this room would not be a good place to be because of just a large span roof. Cars and mobile homes are not good. That little white crumpled car there, that's the car those three chasers were killed in El Reno, Oklahoma. They were actually on a scientific mission. They were trying to put probes out in front of the tornado. The tornado expanded to 2.5 miles just like that, and they got caught in it and were killed. And you can see these cars being stacked up here. I think this other picture is from Joplin, and then here's a car just wrapped around whatever that is, a tree or a pole there. So cars are not a good place to be. And then mobile homes. You know, mobile homes are very dangerous because something that just might provide minor damage to a house can completely destroy a mobile home. The problem is, in our rural areas, we have a lot of mobile homes. We have a lot of folks in mobile homes. As you saw earlier, we serve parts of Georgia and Alabama. You know, I go through my rural counties, and there's lots of mobile homes. And I get asked, what am I supposed to do? If it's 2 o'clock in the morning and I get a tornado warning, where am I supposed to go? And I turn that around. You tell me, where should you go? This is when they should be thinking about that. Maybe if there's a tornado watch issued before you go to bed, maybe you find a neighbor who has a substantial house that you could live in. Maybe you have a relative that actually has a house that you could sleep in. So, you know, mobile homes are very susceptible. It seems like tornadoes seek out mobile homes. It's not really true. It's just that the tornadoes do more to mobile homes. So it looks like, you know, it goes in a straight line and it does very little damage to the homes, and all of a sudden you just got mobile homes destroyed. It looks like it's zipping through and taking out mobile homes. I get questions about what to do if you're outside. Well, your options are pretty bad, to be honest with you. But you know, you want to get as low as you can do. Here's someone huddling under near a ditch there, covering their heads. You know, you don't want to get up into underpasses. You know, there was a video from the early 90s from Kansas where they survived up in the crawling up in the underpass. The problem is that if you take wind and you compress the distance, it's going to get faster. I mean, the area that the wind's going to pass through. So you're actually getting faster winds through there. It's more likely to suck you out than if you're actually laying in a ditch out in the open. Flash flood safety. I just tell kids, stay out of flooded water. Most people with flash flooding are in automobiles, the fatalities. People are surprised at how little moving water it takes to take your car and sweep you right off the road and into the creek. If you see someone that you can barely see, but someone's clinging onto a roof, and that's in Texas there. So we tell people if the road's underwater, just turn around. Turn around, don't drown, is what the message is. And trying to get that out there to more people. Flooding is a real problem for our area. This is something that's another big concern for mine would be the tropical storm Debbie, what it dumped into Wakulla County, 30-something inches in a day. If we had that over the city of Tallahassee, we'd have been on the national news. It would have been a catastrophe. Because we haven't built infrastructure, nobody builds infrastructure to handle that much water all at one time, especially with concrete. You know, and so all of our drainage systems would be completely overwhelmed, and it would have been a major disaster. And that's one thing we are prone to is major flash flooding. Lightning, we tell the kids if thunder roars, go indoors. We don't tell people to count anymore. Basically, you can't have thunder without lightning. So if you hear thunder, you have to have lightning, because lightning causes thunder. So you want to avoid tall trees and objects. Another thing, you don't need rain for lightning. A lot of kids will think, well, it's not storming out, even though I'm hearing thunder, so I can wait. witnessed Little League games where everyone runs from the rain even though it's been thundering for about 10 minutes. Once the rain comes, now they're gone. It really needs to be, once you start hearing thunder, that's when you need to go. One thing about lightning is lightning, actually, you have the different variance in charge between the cloud and the ground. Fortunately for us, air does not conduct electricity very well, or it'd be zapping us all the time. But it does try to. So you have leaders. It actually have leaders coming down from the cloud and leaders coming up from the ground. And where they meet, you complete a circuit and boom, you get a strike, an instantaneous strike. We don't know as a science how that process really works, which storms are going to produce a lot of cloud-to-ground lightning and which aren't. A lot of them have in-cloud lightning, and you hear the thunder, just rumblings in the clouds. You don't get a lot of bolts coming down. But at some point, it transitions to where you start getting a lot of lightning. If those leaders that are coming up, if you ever see this, that's not good. Because that's what's happening to this young lady here. Is those leaders, those invisible leaders, are going through here and trying to connect to the cloud. She was struck by lightning shortly after this picture was taken.
Really?
Yes, she survived, but her brother did not. But they didn't realize what the danger they were in, and that's kind of what we deal with our field in general. People a lot of times don't realize the danger they're really in. So, as a meteorologist, how do you try not to be too alarmist, but let people know what the possibilities are out there? But yes.
On the squat down, do you put your knees on the ground or you keep your knees off the ground?
You would want to go into a ball the best you could. You want to minimize the space and get as low as you can. If you laid flat, it's a bigger area to get struck, so you kind of want to go into a ball. Unfortunately for me, I don't have hair to go through that, so I wouldn't have any clue. But you want to be as small as target as you can. And since air doesn't conduct electricity very well, it likes to go through objects. That's why the taller objects get struck. That's why people stand under a tree to get out of the rain, but they're actually at more risk for lightning. Being under an open gazebo, like a picnic area, that's not a safe place, because if you look back, some of these leaders can actually go sideways. It's not just a single bolt that goes up and down. A lot of times it can kind of come out. It comes sideways. So you want to put as much between you and the electricity as possible. Cars are not a bad place to be. It's not ideal, but it's not bad because that metal shell that you're under kind of conducts these leaders around you. It's not the rubber tires that insulate you, it's just that metal shell. So if it's a convertible, that's not a good place. But a car could be. So anyway, that's about all I have for my presentation. And if you don't have any questions, we could. They're going to bring a mic back to you. Working. I'm going to turn up a little bit. I think it's pretty good.
Tallahassee seems to be a popular place for lightning to strike. How effective is lightning protection?
In what way? I mean, if it's designed to divert a bolt like around a house, that they are pretty effective. If you can provide a channel for that electricity to go down, that's easier than going into your house. It is. Is that what you're asking about?
Yeah, I've heard of the cone protection.
Yeah, and we actually had to build that on our radar. Our radar got struck so many times that the negative charge got blown out of the ground that we were using. And we lost our radar so much a few years ago in the summer that we actually had to come and completely reground it because it got struck so often. So it had been working. It had been getting struck and going around and getting charged out properly.
You have put out two concepts, impact or improbability.
Right.
And it seems to me that part of your job would be to educate people about the word probability. In other words, if you put out a warning, like we frequently get things from FSU, like comes down on your cell phone, there's something, warning about something on campus, then you ought to give them probability with it. You ought to educate people about the probability. Now, as far as the impact is concerned, there's some minor issues that I think I have with your forecast, you say it's going to rain. Well, is that just going to be a drizzle, or is it going to be a big rain? You know, I mean,
Right.
I think you need to qualify some of these forecasts and educate people on the two concepts of impact and probability.
And you know, we do try, and you know, obviously as a scientist, our minds like numbers, we like probability, but there's a segment of the population that we found doesn't, and they don't understand it. And so we try to educate the best we can. And I agree with you. And there's a big debate within our community whether or not should we go with probabilistic warnings. Instead of saying tornado warning, non-tornado warning, you give people a threat of numbers. But then the other part is, as a decision maker, what do you do with a 40% chance of a tornado warning? What do you do with a 60% chance? And so those are the questions that would come back at me, and then it's like, well, it's really up to you to decide what your threat level is going to be. But that's one issue that we are debating within the kind of weather community, how to deal with that. With the impacts, and we try to put maybe light rain or heavy rain verbiage, but a lot of the impacts we don't, I'd like to say we know, but we don't really know. We don't withhold a lot of information. You know, we're not trying to be like, well, if you pay me on the side, I'll give you the real forecast. This is what everybody else is going to get. But you're right. I mean, you know, there are times we'll say there's a 40% chance of rain, and that could be a downpour or it could be a sprinkle. What we're actually forecasting is measurable rain, 0.01 or greater. But it doesn't help people a lot when they don't really know what to plan for on that. So I agree with you, and we are trying to do the education route the best that we can.
I was recalling a hurricane from 2004, and the reason I was recalling it was because I can remember that people were coming from west of here, coming to Tallahassee, to schools, hotels, etc. And it just made me wonder if you're really advising seriously about a tornado or a hurricane. If you would advise people which roads to begin taking, maybe that would urge them on. I mean, they might take it seriously. These are the roads we're recommending you use in order to find shelter, obviously.
And we're trying to do that, and that's where we're trying to work closer with emergency management to find out what evacuation routes that they're going to be opening up, and then so we can use some of our information to help get that message across. And so I think that you'll start seeing over the next 5 to 10 years a greater message there, a more consistent message, where we can actually say what roads to take and things of that nature. One thing about it, like a hurricane evacuations, is a lot of people don't realize that you really kind of want to get out of that cone. It's not just about getting inland. Hurricane Charlie, when it was threatening Tampa, everybody left Tampa and fled to Orlando. Or Orlando was still in the cone, so they left an area that didn't get hit and went to an area that got hit. It could be the same way here. People could want to go from here up towards Albany, Georgia, or Valdosta, or Macon, and still be in the path of that storm as it comes inland. It won't be as intense as it is here, but they might have been better off going down towards Gainesville or or Orlando, depending on the track of the storm, or maybe out west towards Pensacola. So and those are the type of messages that we can try to do a better job with. I agree, and giving people some more advice. We try not to tell people what to do because we don't know everyone's situations. So and you hate to give someone bad advice, obviously, but.
Are lightning rods a good idea or a bad idea, or they don't matter anymore because we have surge protectors, or what?
No, I think lightning rods are a good idea. If they're installed properly, they still work. They do still work. I mean, a surge protector is backup for that. But the more you can divert the electricity away from where give it a channel to go down, the better off you're going to be.
Anyone?
So given that our sponsor is the MagLab, and you may not have lived here long enough, why is it that rain dissipates over Tallahassee when the magnets are on? No, but seriously,
It's a trade secret.
Yeah. The serious question about that is, people made that response because of what you see. You see clouds come in from the west, and then they open up over Tallahassee and they go away. What is it about our geography that maybe explains that?
Well, a lot of it has to do with understanding radar. And so what you're seeing is, remember, as the beam goes out, you're getting higher up. So maybe those clouds are at 10,000 feet, and as they get closer and closer and closer, that If you're just looking at that elevation scan, now it's undershooting those clouds as it gets in, and then as it comes out the other side, then the beam the other side starts hitting it again. Does that make sense?
Oh, absolutely.
I realize this is not a sexy question like the rest of them, but here's what I always wondered about the rain. And they tell you how much rain has fallen in any one area, like in Tallahassee. It's just one spot as opposed to 22 spots when they take the average. And is that because historically it's only been one spot?
Yes. No, I'll expand. We basically, the climatology is at the airport. So the high and the low and the rain you get for Tallahassee, turn on the news, the high today of Tallahassee was this, it's at the airport. So we want it at the same site with the same instruments so that we can maintain a climatology. Now we do have storm spotters around the city, and when they report their rain, then we'll put that out. We will say, somewhere, maybe just off Bannerman Road, we had 4.5 inches yesterday, and the airport might have had 2. So we will try to share that information if we get it. But a lot of times we don't get that information, and so the only one we get is from the sensor there at the airport.
Well, let me ask you another question. So scientifically, that's not really representative of what we're really getting in Tallahassee. I mean, you're down there in the karst, you're already down the flatlands.
Right.
And I know historically that's where it came from, and I understand that. But I think there needs to be a different thinking about that philosophy on how they report that.
Well, I mean, the reason they put it at the airport is because that's where it's been for a long time, and so you have a long history there. If we move it, then suddenly you've lost all that history, and you can't compare apples to oranges now when you start looking at. There's a lot of talk about climate change and things. But how do you measure 100 years of climate if the sensors move? It's the same thing with urbanization. How has that influenced things with climate records and stuff? It's a hot topic, so to speak, with messing with climate records.
There is no real answer.
There really isn't, and that's a part of the problem. Just like the example I said with a 40% chance of rain, where someone's saying they didn't say it was going to rain, the other person said they said it was going to rain. How do you deal with that?
I have a question about hurricanes. Tallahassee is about 60 or 80 miles from the shore. So if let's say a Category 3 hurricane came, how much would it weaken over 80 miles or 60 miles?
A lot of it will depend on how fast that storm is moving. If you have a hurricane moving at 20 miles an hour, then it only has an hour to weaken before it would have hit us, so it wouldn't weaken very much. If you have one moving at 8 miles an hour, it's going to have more time to dissipate, but it's going to give us a longer duration of winds. Either one of it's going to be fairly catastrophic. But it's a good question, but we're not far enough inland that we would not see a significant impact. If we had a Category 4 storm make landfall at Carabel or at Apalachicola, we would receive a wallop like we would not imagine here, because we're not far enough inland. Katrina, for instance, they had hurricane damage all the way up, hurricane winds all the way up almost to Meridian, Mississippi. Hundreds of miles inland, where they actually still had hurricane conditions. The same thing with Hurricane Hugo in 1989. It made landfall over near Charleston, South Carolina. All the way up to Charlotte, North Carolina, they had hurricane force winds. So 120 miles inland.
They were much weaker.
They were weaker, and they will weaken once you get off of that warm water. So if we had a Category 4 storm on the coast, maybe we deal with high-end Category 2, low-end Category 3 winds here. Either one of which would be really, really devastating. But a lot of it just depends, like I said, how much time it's off of that water, because they will weaken relatively quickly once they get off of their fuel.
Any other questions?
In 2008, I can't remember the name of the hurricane, but it hit Texas. Do you happen to remember which one that was?
Hurricane Ike?
Yes. At that time, I drove up to Ohio, missing the hurricane itself, But by the time I got to Ohio, the northeast quadrant of Ohio, a large portion of the state had been blackened. I mean, there were serious power outages.
From the remnants of ice?
From the wind.
Right.
It's hard to imagine that the wind could sweep up that far north and east and do such damage. And I was really puzzled by that.
Well, what happened with Ike, it didn't have a swath of wind from the coast all the way into Ohio. I mean, the remnants got up and then it got picked up by another weather system and kind of re-amplified again as it got up in there.
Okay.
And so we had a lot of severe weather with that once again.
All right. Well, I was trying to imagine a hurricane of that size that it could sweep so far north of the
Right.
state.
No,
So,
it wasn't a direct swath, but
Okay.
the remnants of these storms do a lot of damage. I mean, Agnes, which made landfall near here in '72, wasn't much of a storm, but the flooding in Virginia and West Virginia was catastrophic. We had, I think, 270 people killed from flash flooding from Agnes, just with all that moisture and the remnants of that storm.
thank you.
Did the no-name storm that hit in the 90s?
Right, the superstorm?
Yeah, did it just form over the people that it hit? I mean, was there like no warning?
There was a coastal flood warning out, but back then we didn't have the buoy data we do now. Nobody knew the magnitude of the surge, and nobody could really comprehend that we would get a hurricane type of surge with a extratropical normal winter low with a cold front. So, you know, the storm she's referring to, there were 12 people that drowned not that far from here in parts of Taylor and Dixie counties along the coast from the late night surge with the superstorm as it came through. And so there really wasn't not a lot of notification then, because a lot of it we didn't have any anticipation that the surge was going to be that strong. Since then, because of that storm, we've done a lot of modeling and we do have more buoys. We don't think we would see a replica of that. We think we'd be able to model that more accurately and get people the notification they would need.
They also built the houses higher.
They did, yes, they did build the houses higher. They increased the codes quite a bit. And speaking of codes, you know, after Andrew, there were a lot stricter codes and a lot more building codes. Well, we have a lot of stuff built well before Andrew. So we haven't had our Andrew storm yet, where they're going to rewrite codes.
How can we be safe anywhere? It doesn't sound like it could if it really hit us.
Well, in Tallahassee itself, you probably wouldn't be. And the tough thing is we evacuate typically from the water. So we tell everybody on the coast they have to evacuate. And our coastal residents are really flood savvy because they deal with, our bay is one of the most surge prone areas of the country, the bay in there, because of how it's shaped and how shallow it is. And they've dealt with it a number of times. Dennis recently had 8-10 feet of water on them. So they're used to that. They evacuate. The inland areas, we don't. There are no mandatory evacuations. So that puts a lot of impetus on someone like me to have that messaging to tell people, like, you know, you don't have to leave, but I really wouldn't want to be here. You know, unless you're prepared to be without power for 2 weeks and to not have any food, medicines, or anyone can get to you if you're hurt, you really don't want to hang around. The question is, how much notification can you give people? You know, if I do that at 2 days, and then like in Ivan, and it goes west, and everyone's going to get really upset. You know, and so you can't cry wolf, but you have to let people try to hopefully make the right decisions to just get out. I know if we have a major storm moving this way, my family's going to go. I'm going to send them off, and I'm going to go to work.
But go where?
Well, away from the storm track. It's going to have to vary, and that's the things that you have to think about. Well, yeah, maybe they'll go to Montgomery, Alabama. Maybe they'll go to Orlando. Maybe they'll go up towards Macon. Depends on where we think the storm track's going to go.
So is that 2 weeks? Is that your benchmark?
For power outages?
Yeah, just for withstanding.
You know,
Repeat that question.
okay, he was asking, is 2 weeks like a benchmark for people to be without power? That's a tough one. What do you think you would do without power? I mean, how long? Just asking.
How long would I do?
Right. How long would you go before you were like, I gotta get out of here? I mean, for my kids, it would be like 6 hours.
The reason I'm asking is I would like to know what I should prepare for.
Right. We prepare people. We tell people to prepare for a week. A week's water, a week's food, a week's medicines. You know, cash. unless you're going to start bartering chickens because the ATMs aren't going to work, the credit card's not going to work. Yeah, you got chickens, you're good. But I know after Andrew, that was an issue with people needing things, but what are they going to pay with? If you run a store, you'd like to think, you're just not giving your stuff away, so that was an issue. People with cash did a lot better after a big event, unless they have a lot of chickens. So. But the power outage is going to vary for folks. Like I said, my kids wouldn't go but about 6 hours. So.
We sort of solved that problem for our house by buying a generator in the backyard, and the most it's been out is about 5 hours when our neighbor's tree brought down a line. But we could take 2 weeks if we had to.
Right. You'll be the only one with air conditioning, so everyone's going to your house. I can hear that generator running.
What was that address, please?
Yeah. With Isaac, a couple years ago, we were threatened by Hurricane Isaac, which hit New Orleans. And on Friday, before Isaac, it was about 4 days out, I was out there starting my little generator. And so my neighbors are like, why does the weatherman start his with his generator? What is it that I don't know? But so we have a little generator as well. But the other thing even if you have a generator and you think I'm going to ride this out, look what kind of trees are around you. Are you going to have a survivable structure if you have a 50-foot pine tree come down right across your living room? I don't know. I mean, hopefully we won't be dealing with that. But good.
I have a good friend who left Key West during Wilma and was a refugee in Tallahassee. He had a nice house with a 15 kW generator powered by propane in Key West, and after he arrived here, he was calling his home about every 3 hours and asking people what was going on. And I finally asked him, what is going on? He said, well, I got about 15 people that are staying there, and I tell them, raid the refrigerator, drink the wine, go ahead and have some of that good bourbon and keep the air conditioner going. And I said, isn't that expensive? And he said, well, a lot less expensive than if the house was looted.
Very nice.
You mentioned that we're more sensitive to like a Category 1 than Miami would be.
Right.
Can you speak to why? What makes us?
Well, because of our vegetation, really. We have so many trees. We have a lot of above ground power lines. A bad combination. But really, we just really, South Florida, the hurricane frequency is so much higher down there, so they don't have the large trees, and there's a reason. You get south of I-4, you don't get the big trees anymore. Well, because the hurricanes have mowed them down over the years. They're just not allowed to grow that high. So that's the big issue. We would really be more like New Jersey. I mean, if we had to, or Rhode Island, as far as our infrastructure, as far as our susceptibility to a hurricane. In parts of Jacksonville are the same problem. They haven't been hit in over 100 years, and they've got the big trees, and they got a bigger metropolis, more near the water. So we have a few parts of the state that are our big problem. Tampa Bay is a disaster waiting to happen. All of that development's occurred near the coast. You've got people who built these $1 million homes, and they have like a 2-foot seawall. It's not going to take much.
I just moved from Tampa, and people always said that it wouldn't hit there because of how they're situated. Is that just a rumor?
That's just a rumor.
Okay.
Everybody always says that, yeah. Everybody always says, where I came from in Norman, Oklahoma, the Canadian River protects us from tornadoes. Or there's an Indian burial ground that protects us from tornadoes. Everybody always has something that's going to protect them. But none of that's really true. It's just that the fact, in our lifetimes, nobody really gets hit very often by anything. I mean, the folks in Joplin, Missouri hadn't been hit in a tornado in hundreds and hundreds of years, but they got one. Nothing was really protecting. It was just that they just happened to be getting lucky all those years. And we've been lucky a long time in Tampa. We've been lucky here. We don't know if it'll be this year. The Northeast. The Northeast had been spared for years and years and years. They just had two. They had Irene and Sandy in back-to-back years, just a couple years ago. So Florida actually hasn't had a hurricane since 2005, which is remarkable because we had more than we wanted for 04 and 05, and then we haven't had any since. So we are way overdue for a hurricane. Just knock on wood, right?